Okay, so in this video, I'm going to go through question 7. I can leave answers in terms of pi. Let's just go off there. Can you still see that? Yep. And calculate with the area of a circle. Okay, so this is section 7, but again, because of the way this booklet's put together, it's actually section 6, and it's on page 6 of 23. If you sort of look through the bottom there, that's the easier way to find it as we work further and further into this booklet, revision booklet. Right, I'm going to come on to that question in a second. At the start of this, question, you are given two quite similar looking calculations. Now the first one looks like this. Okay, as I say, just ignore what's there for the time being. I'm going to write a couple of things that you need to be able to calculate with basically. So let's say we have 17 pi minus 2 pi. Okay, so that's what the first question looks like. Now when you get pi like this and it asks to leave your answer in terms of pi, all you do is you treat the pi as if it is just a normal letter. If this was 17x minus 2x, our answer will be 15x, but it's 17 pi minus 2 pi, so our answer there is just 15 pi. Okay, so do me a favour, just pause the video and have a little go at this one. What's 12 pi minus pi? Okay, 12 pi minus 1 pi, your answer there should have been 11 pi. And the second part of that, that's like part I, is a very similar looking question, but something like this. What's 15 pi divided by 3 pi? Now, this one, 15 divided by 3 is 5. Pi divided by pi is 1. Because whatever number pi is, like 3.14126, whatever it is, divided by itself, pi divided by pi will just give you 1. So effectively that's 5 times 1, which just leaves it as 5. Okay, so again, just have a go at this question, pause the video and just try this question please. What's 20 pi divided by 5 pi? Yeah, your answer there is 4. So when we're taking them away, we still get a pi. When we're dividing them, the pi's cancel and just leave us with an integer. Okay, so those are the first two parts of this question. Second part of the question is all about calculating with a circle and then another shape. Okay, so let's have a little look at what we've got here. XZ, which is that line there to there, is the diameter of the circle centred at C. So remembering from your circle theorems, a diameter creates a right angle in either sector. So it didn't really need to put a right angle there, but it's done that to help you. So XYZ is a right angle. This one is 8, this one is 6. Calculate the radius of the circle and the total area of the shaded regions. Now, for me, it didn't need to say that bit. This is a better question if they ignore that and just get you to do this, because it's kind of implied that you have to do that. So we've got a right angle triangle where we don't know the hypotenuse, so what are we going to use to figure it out? Yeah, we're going to use Pythagoras. Okay, so remember that this is on a non-calculated paper. So 8 squared plus 6 squared square rooted is going to give me the answer. Now you might sort of see this differently depending on your class you're in. I get my class to do it like that because I can just shove it in a calculator. Obviously now we can't put it in a calculator, so what we have to do is work out the bits separately. So 8 squared is 64, 6 squared is 36, 64 add 36 is 100, so I'm doing root 100, which is 10. So that means that that distance from there to there is 10 centimetres. Now that was the diameter, so what must the radius be? Well, the radius is always half of that, so the radius is 5 centimetres. Okay, so if I want to figure out the total area of the shaded regions, well, the shaded regions are the circle take away the triangle. So I need to figure out the area of the circle and then take away the area of the triangle. Okay, so I need to do the circle minus the triangle. The reason for that is because the area of the triangle there is taking up some of the space of the area of the circle. So a circle, remember, is pi r squared, so I'm going to do pi times 5 squared and work that out. Take away the area of the triangle, which is base times height divided by 2. So the base is 6, the height is 8. I'm going to do 6 times 8 divided by 2, or times a half if I'm going to write that. So pi times 5 squared is going to give me 25 pi. Remember, if you put that into your calculator, your first answer always comes up looking quite nice. which is weird because obviously pi, anything to do with pi is going to be a horrible decimal number. So when I do pi times 5 squared, the first answer on the calculator that it will give you is 25 pi, and that's how you want to leave it. Okay? Take away 6 times 8 is 48, divided by 2 is 24, so that's my answer. 25 pi minus 24. Okay? Anything where you are dealing with circles on the non-calculator paper, you need to get used to leaving it in terms of pi, which is why they sort of start you off with these two things up here. Okay, so we can't divide that or anything, and we cannot subtract 24 from 25 because that's got a pi and that hasn't. So my answer there is just left like that.